In the previous videos, I built a system that uses an LLM to interview users, translate their answers into structured evidence, and then runs their evidence through their Bayesian network. The system can estimate the likelihood of a security risk, different incidents, and business outcomes. But there is one major problem with the current architecture. Most of the expert knowledge, if you remember, is stored in JSON files. And JSON work well for the execution, but it doesn't work in a particularly nice way for understanding the entire security model. As the number of controls, risks, incidents, and business outcome grows, it becomes increasingly difficult to answer a simple question: how everything is connected. And in this video, I will introduce the next evolution of the project. I'm moving that expert knowledge into Neo4j, so the security model becomes a visible, explorable graph. So until now, each security expert has been represented as a JSON file. And for example, an IAM expert, my favorite one, might contain controls such as multi-factor authentication, the usage of shared accounts, and so on. Those controls are then connected to IAM risk or number of risks that this expert owns, and then those risks are connected to possible incidents in a different network, in a different JSON file. And even more than that, those incidents are connected to different business outcomes, such as revenue impact or regulatory impact and customer impact potentially. And conceptually, what I just described, it's kind of already a graph. Control influences a risk, risk influences an incident, and incident influences a business outcome. And in a current implementation, those relationships are distributed across multiples of those JSON files. And if you would want to introduce something more complex, say one control can influence risks for both IAM from the IAM expert and from the network security, for example, then it would be a little bit harder to manage all of that, and you would need to introduce an expert with knowledge of both of those areas. Anyways, JSON was a good starting point. It was easy to generate, easy to version, and easy for Python to consume, and somewhat easy to represent just a single expert knowledge in a limited way. But it became harder to manage as the knowledge model expands. And now I want to introduce new experts and new controls. At the moment, there were only 25 of them, I believe. And now I want to expand this to be a bit more realistic with the interview and with different risks and with different business outcomes. So, to understand that huge model, it became a difficult task. And that's where Neo4j comes in. Neo4j is a graph database, and instead of primarily modeling the information as tables or nested documents, we represent the system using nodes and relationship between those nodes. And in this project, specifically, the nodes could include controls, risks, incidents, business outcomes. I want to keep the security experts just as an anchor, to be able to query what one expert knows about the security, and it just to keep the mental model as it was before. But technically speaking, experts are not needed anymore. Now, let's take a look what changed in terms of the actual implementation. First of all, the README was updated with additional instruction, and the first thing that we need to do now is to run a Docker version of the Neo4j. You can use a cloud version if you want to, but I decided to stick to the free tier and to run everything locally for now, and that's up to me pretty much. So what I need to do is to start Docker, call it my Neo4j, the container, and it is running happily. Next thing that changed is I changed the experts into another Python script that would be called seed neo4j _ old or CEO neo4j. Those two are two different versions of my expert knowledge, and the neo4j old is the previous version of it. So if we would now run Python seed neo4j old and clear, everything, then we would be able to see something like this. With this query, we can return only the everything that we have pretty much. And is green nodes, I have my Bayesian network. So this one is all of the incidents that are available, and another one is all of the business outcomes. Business outcomes are those yellow nodes with revenue impact or the regulatory impact or the customer impact. Then those big pink ones are the incidents that are available, and they contribute to each of those business outcomes. And then on the very left side of it, we have blue nodes. Those are the experts that can own or influence specific risks and controls, like privileged access management or the IAM no shared accounts and so on, and they contribute to risks, and risks in return they influence incidents. So that model is pretty much what we had before, and if we drag stuff to the left to make it a little bit visible, we can see that the current model was not the best one, let's put it that way. Because what we can see here is that, for example, from the IAM expert, there was a control that IAM excessive permissions, and it contributed to no risk at all. At the same time, I had an expert that is a secrets expert. This expert was responsible only for a single risk called secrets risks. But this one, it did not contribute to any incident whatsoever. So that's an interesting observation. And in addition to that, I had a risk that is called third-party trust risk. That risk was partially significant for the supply chain incident, but there were no controls and no experts who actually own this, and that is another miss. So with a modeling like that, with a tool and visualization like that, it is very easy to see that the current model, while it was somewhat complex, but still had some issues. And it is very easy to find those issues and potentially fix them. But what changed is that now I can run the seed of the new data, like so. And you would be able to see immediately that there are now 71 controls altogether. If we would rerun that same query now, the picture would be slightly different, right? And a bit more interesting. So we have still we have the same incidents, but with some additional ones. We have additional expert, the governance one, and they all have risks and controls, and there are no dangling bits that are not used at all. So this kind of model is a little bit cleaner and a little bit closer to reality, I hope. And altogether, we have now 5 business outcomes that we can control, those being revenue impact, or the operational impact, or the regulatory impact, and is a reputation impact, and the last one is a customer impact. So all of that is influenced by number of incidents and a bigger number of risks and even bigger number of controls. With that model, it would be easier to run some sort of analytics across this one, in addition to the skill to do the magic of the security architect. The last thing that I wanted to show is that we still can run the interface, so the LLM can still interview the user. And for example, over here, I started the interview for the Snowflake platform. First, I started that just one answer that if my security Snowflake platform is subject to security reviews, and I said that no. We updated the input that over here that the architecture review required is none. Then I wanted to describe a couple of controls right away instead of doing them one by one. And the result was that we have query rate limits, we have MFA enforcement and lifecycle management and so on. And it is possible still to run the assessment. I finished after those 5 or 6 controls, 5 controls, and it works as it was before. But in addition to everything, we now have this nice visualization tool, which is very useful. In conclusion, the main purpose of this change is visibility. The project already models the security as a connected system, controls affect risks, risk affect incidents, and so on. But moving that knowledge into Neo4j makes the model easier to explore, expand, and explain, and it is fun to just drag those nodes across their screen. And LLM still remains responsible for interviews and explanations, Python still responsible for that probabilistic inference, and Neo4j now becomes a source of expert knowledge and relationships in a much more easier and manageable way. If you are interested in practical AI-assisted security governance without replacing every component with an LLM, subscribe and follow the series. Thanks for watching.